Today's lesson, we're talking about solving system of equations with two variables. There are three different methods in solving: substitution, elimination, and graphing. Now we'll try to show all three, and then we will also have to be able to apply these to word applications or word problems. So the first one, I chose to graph this one. To graph it, I'm going to set them equal to y, and then use slope-intercept form to help me graph. First one's pretty easy. Just subtract 2x to both sides. That gets in slope-intercept form. The other one, I have to subtract 3x to both sides, and then also divide by 4. Once I have them set equal to y, I need to use the y-intercept of each, and then graph that point, and then use the slope from there to help me get other points. For this first one, because I don't know where the other one's going to be, I usually extend my graph pretty far out and mark all those points so that it's easier for me to determine where the two lines intersect, especially when it's not on a graphing calculator. Then on the second one, you won't need to graph as many points because it will be easy to see where they intersect usually, unless there are decimal points, which does happen from time to time. For this one, it does intersect at a very nice intersection of -2, 5. And so then that would be my answer. If you plan on using graphing, you can use Desmos to help you out, or you can also use your graphing calculator to help you out as well. So you don't have to do this by hand if you don't like to. Okay, the next one, it looks like the y's are set up pretty nicely to cancel out, so let's use elimination. So since they are set up with the same coefficient but opposite signs, I can add them, and that cancels them out, and then I am easily able to solve for x, which is 4, and then I pick one of the two equations that we started with and plug in that 4 for x to help me solve for y, which gets me the value of 1. Okay, so then my answer would be 4, 1. And then for the last one, I'm going to use substitution since we haven't used it. The top equation is set up decently so that I can solve for y if I just add y to the other side. So then using the other equation, I'm going to plug in 4x for the y that I have in that equation so that I can solve for x first. Which gets me x equals 4, and then I go back to the original equation that I solved for to plug in that value of 4 for x so that I can find y, which is 16. So then my answer is 4, 16 for this problem. There are a couple things here. There are different types of solutions you can get. We got mainly one solution with each of those examples, which would be consistent independent. You can also get no solution or infinite solutions. No solution and infinite solutions have the same slope, but it's whether they intersect or not. For our word problem application, for example 2, I have a man that flies a small plane from Fargo to Bismarck, a distance of 180 miles. Because he is flying into a headwind, the trip takes him 2 hours. On the way back, the wind is still blowing at the same speed, so his return trip takes only 1 hour and 12 minutes. What is his speed in the still air, and how fast is the wind blowing? So here, I will need to figure out what my unknowns are. For this one, I don't know how fast this plane is flying on its own, so I need to know the speed of the plane, which I'll set equal to x, and I will also need to know the speed of the wind, which I'll set equal to y. From there, I would like to kind of write out what I do know from this problem as well. So it helps me set up my equations. It looks like the distance for both trips is 180 miles. Then I also know that the time that it takes to go into the wind is 2 hours. And then also the time that it takes to go with the wind is 1 hour and 12 minutes. Remember that 12 out of 60 minutes for an hour is going to be 0.2 or 1/5. You can use a decimal or fraction here. I used a fraction, so I wrote 6/5 as an improper. One thing you'll need to know for this is that for a rate of going with the wind or against the wind has a different ratio. So going into the wind, it's your speed minus the wind speed. And then going with the wind, it's your speed plus your wind speed. So you actually get a boost. So that actually represents rate. So we actually know distance and time and rate, so we're going to use the formula of distance equals rate times time to set up our equations. So for the first one, going into the wind, it takes 2 hours times the rate into the wind, which is x minus y, which equals 180. The second one, I would use 6/5 as my time, times the rate, which is x plus y in this case, equals 180. And then I kind of have to manipulate them a little more so that I can get them set up to solve a little nicer. I chose to distribute 2 through and 6/5 through to kind of get them so they're not in that form anymore. And it looks like that the y's cancel out nicely if I multiply the top equation by 3. So I do that. And so then I add my two equations together so that I can isolate x and solve for what it is, which is going to be 120 miles per hour. So once you know one of the variables, you get to go back and pick which equation you'd like to use. Looks like I used the first one, and then I plug that in to help me find what y is. In doing so, y will be equal to 30 miles per hour. So in conclusion, I know that the airplane's speed is 120 miles per hour and the wind speed is 30 miles per hour. Hopefully you found this video to be helpful. Thanks for watching.